Welcome to qiphyedu. Today we'll be looking at computer science A2 level, paper 31, October-November 2022. Alright, let's start. Okay, so for the first question, it says real numbers are stored in the computer system using floating point representation with 8 bits for the mantissa, 8 bits for the exponent, two's complement form for both mantissa and exponent. Write the normalized floating point representation of positive 202 in this system. Show it working. Okay, so you can see that there's no we don't need to cover numbers like 0.5 and 0.25, so that is completely omitted out of this number because this is a whole number. So we can just directly take the rightmost bit here, and then we can start off with 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, until 2 power 6, because the most significant bit or the leftmost bit is used to indicate whether or not this number is a positive or negative number. In this case, this number is a positive number, so we just put 0. Okay, and then here you realize that there's an issue. The issue here is that 202 is already more than 128, and that requires 2 power 7. Therefore, we need to shift the entire thing to the right, like moving the rightmost bit to the right, so omitting out 2 power 0. Okay, so by doing so, the rightmost bit at the moment will be 2 power 1. Then here we add 2 power 7. Okay, so 2 power 7 would be 128, 2 power 6 would be 64, 2 power 5 would be 32. So you add all together, you'll get 224. This has already exceeded 202, so we can just remove 2 power 5, and then we'll get 192. Okay, so we can just put 1 here, and then if we take 202 and minus 192, we get 10. So 10 can be represented by 2 power 3 and also 2 power 1. So for 2 power 5, 2 power 4, we can just put 0, and then for 2 power 3, we can put 1. So let's take 202 minus 192, we get 10, and 2 power 2 just put 0, and 2 power 1 just put 1. Okay, and now we need to do the exponent. So we need to start with the dot between the 2 bits here, the first bit and the second bit, and then we need to move it all the way to the back where we meet where the dot meets the bit of 2 power 0 and the one on the right, basically. So just move this to the right like this: 1, 2, 3, 4, 5, 6, 7, and 8. You need to remember that this is the empty space for 2 power 0. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 would be 1, 0, 0, 0 in the 2-bit form. So that would be 0, 0, 0, 0, 1, 0, 0, 0. This can be done. This can be proven by starting from 2 power 0 on the right. So 2 power 3, we get 8. So this is the answer. All right. And then we move on to B. Now we need to write the normalized floating point representation of negative 202 in this system, and we need to show our working. Okay, so for this one, what we need to do is just change everything from here. Change most of the bits from here into like change 1 to 0. So first we start with the most significant bit, just change the 0 to 1. But you need to remember your bit on the right hand side must be 0. Okay, and then regardless of what number this is, this one has to be a 0. Okay, remember 1, then it followed by 0. Then this one, 2 power 6, change to 0, and then the zeros on the right, we just change to 1, and then this one is also 1 change to 0, and then 1, and then 0, and then here there's a problem. You need to remember that for the rightmost bit, it has to be 1 as well. So you need to leave the 1 on the right hand side. So the 0 must be changed to 1 like this. Okay, and you need to remember that the second bit on the right hand side of your most significant bit basically has to be 0. Okay, so with that done, it's also the same thing as the top exponent, also 8, so there's positive 8, so that'll be 0, 0, 0, 0, 1000. Okay, so this is the answer. Okay, then 1C1, the binary number is stored in the computer system and state why the number is not normalized. Okay, then the answer for this one will be the second bit, or you can just say the mantissa does not begin with 0, 1, or you can just say that the first two bits are the same, or first two digits are the same. Okay, then for 2, we need to write the normalized floating point representation of the number. So move everything here to the left. That means it will be something like 0, 1, 1, 1, 1, 0, 0, 0. And then by doing so, because here you need to look at the exponent as well. The exponent is basically let's calculate it. It's 24. So when you move to the right, you move to the left, that would be 0, 1, 1, 1, 1, 0, 0, 0. Then you don't need to move 24 places to the right. You need to remove you need to remove 2 from the exponent. So this will give us 0, 0, 0, 1, 0, 1, 1, 0. Right? So yeah, that will be the answer, because as you can see here, you always have to remember that in order to calculate exponent, you need to calculate from the dot between the most significant bit and also the second bit. By moving to 2 places to the left, it starts from here as well, but immediately on the right hand side is 1 already, and you already remove 2 empty bits. 2 empty digits are basically 0, so that's why it's -2. So 24 minus 2, you get 22. Okay, then question 2, outline the functions of the transport internet layers of the TCP/IP protocol suite. Okay, the transport layer basically breaks data into manageable packets. It adds the data to packet header, and sends the packet to the internet layer. Okay, then the internet layer identifies the intended network and host. It routes packets independently through the optimum route, and addresses packets with their source and destination IP address. Okay, question 3, state what is meant by the term enumerator data type. It's basically a user-defined, non-composite data type with an ordered list of values. Okay, and then pointer data type is also a user defined non-composite data type. Put a dash in the middle. Data type used to reference memory location. Okay, then C, the months of the year are January, February, March, April, May until December. Write the pseudocode statement to define the data type Q1 to hold the names of the first 3 months of a year. Okay, so for example, first 3 months of the year will be January, February, and March. So type Q1, that will be January, February, and March. Okay, then D, the composite data type pet is used to store data about the various pets of a group of students. It uses these fields and write the pseudocode statement to set a variable for one record of the composite data type pet. Okay, so everything that is inside here all reference to the basically the data type pet. So now we just need to set up a variable for this record. So declare, you just put in any name. In this case, I'll put pet1, and then we just put pet. Okay, this is the answer. And then 2, write pseudocode to store the details of the following pet in the variable set up in pet d1. Okay, so what we do is we just take pet1, put a dot at the back, and put pet name. You put an arrow. This one, the name is Tibbles. Then pet1 dot animal type. Then just put in, you have reference back to the table, the animal type is string, so we need to use the open and closing brackets like such. And then pet1 dot pet age. Okay, the pet age here is in integer form. This one is 8. Then pet1 dot pet gender. This one is character, so only 1 comma, 1 inverted comma for left and right. And then pet1 dot owner name. Pet1 dot owner name, you get Jasmine Smith, 2 inverted commas for each side. Okay, done. Then question 4, draw one line to connect each stage of compilation to its most appropriate description. So lexical analysis would be converting a sequence of characters into a sequence of tokens, so this one, followed by syntax analysis, which is to use parsing algorithms to interpret the meaning of a sequence of tokens, because it's followed after lexical analysis. Then code generation is to convert an intermediate representation of the source code into executable, this one. And finally is to minimize the program's execution time and requirements to optimization. Right? Remember to use a ruler. The reason why I'm just using my freehand to draw is because there's no rule feature here. Alright, so I'm just gonna draw it like that. So remember in the exam, please use a ruler. Okay? So 5a, we need to write the infix expression in reverse Polish notation. So this one would be, we need to look at the symbol. This one has to go to the back of B. So this one is AB star. Okay, I think I'm just gonna draw like this, make it easier. And then it has to be, this one is plus B minus D. This one is B plus B. You need to look at, because there's no bracket, you have to look at it as B plus B. So then it's B plus and then D minus, because it's B minus D, so D and then minus and then 15 plus. Okay, then we need to write the Arpean expression in infix form. This one is A minus B multiply C plus D divided by A. So your A minus B must have brackets, and also for your C plus D. Okay, so this is the answer. And evaluate infix expression from part B1 when A equals 5, B equals 10, C equals 27, and D equals 12. Okay, so A equals 5 and B equals 10. So 5 minus 10, we get negative 5. Multiply C plus D, we get 39 divided by 5. So you'll get negative 39. Okay. 6. A message is encrypted using a private key and sent to an individual using asymmetric encryption. And state what is meant by private key. A private key is basically a key. It is the key that is not published anywhere, because the one that's published anywhere is the public key. It has a matching public key okay. It is used to decrypt data that was encrypted with its public key. So basically your public key is used to encrypt the data sent by the sender, and then the receiver would then have the matching private key, which is then used to unlock the data. Okay. B. Describe the process of asymmetric encryption. The message is encrypted using the receiver's public key. The receiver then decrypts the message using their private key. Okay, that's how you get the 2 marks. C. Explain how a digital signature is used to verify a message when it is received. Okay, the message together with the digital signature is decrypted using the receiver's private key. Or you can just say decrypted using private key. It's the same thing. The digital signature received is decrypted using the sender's public key, to recover message digest. The decrypted message received is hashed with hashing algorithm to reproduce message digest of message received. The 2 digests are compared. Okay, you already get 4 marks, but then we just add the last one. If both of them are the same, the message has not been altered. Okay, so that's how you get 4 marks, or actually 5 marks already. So first of all, the message with the digital signature is decrypted using your private key, and then the digital signature is then decrypted using the sender's public key, okay, because the digital signature can be identified by using the sender's public key to verify its authenticity. And then it can also be used to recover the message digest. And then the decrypted message received is then hashed to get the message digest. You need to compare the two message digests, and then if the two are the same, then the message is not manipulated in any way. So this is how the message is, how the digital signature is verified. Okay, then now let's look at 7a. We need to complete the Karnaugh map for the Boolean expression, not A, B, not C, not D. Okay, so not A, B, not C, not D, that will be 0, 1, 0, 0. So that put 1 here. And then not A, not B, not C, not D, so that will be 1, 0, 1, 0, which is here. Sorry, 0, 1, 0, 1. It should be 0, 1, 0, 1 because not A, B, and not C, D, so 0, 1, 0, 1, which would be here. And then A, B, not C, not D, that will be 1, 1, 0, 0, which is here. And then A, B, not C, D, that will be 1, 1, 0, 1, which is here. And then A, not B, not C, not D, that will be 1, 0, 0, 0. So 1, 0, 0, 0. And then A, not B, not C, D, that will be 1, 0, 0, 1, so that will be here. So everything else would be 0. And then we need to draw loops around appropriate groups in the K-map to produce an optimal sum products. That would be this and this. Because for the left group, they all have one similar characteristic, which is not C, and also B. And then for the right group, that will be A, and then not C. Right? So we need to write the Boolean expression from our answer as a simplified sum of products. We need to write the Boolean algebra to give your answer in the simplest form. So this one would have to be this one you can see that B is, both of them have is B basically is 1. So B and not C. So B not C plus, and for this one, for the right group would be A and not C. So something like this. Then the simplest form would be not C, B plus A, or you can just say A plus B. Okay, if you prefer A in the front, then just put A in front and B at the back. Okay, this will work as well. Then 8, we need to explain what is meant by virtual memory. Okay, virtual memory is basically a memory that is extended using secondary storage. In this case, that will be your SSD or your hard drive. Secondary storage, which allows CPU to access more memory space. Okay, then only data in use needs to be in main memory. So data can be swapped between RAM and virtual memory. Between RAM and virtual memory. It is temporarily created. Okay, so in order to get your 3 marks, actually it's already 4 marks. If you look at the first sentence, it already gives you 2 marks. Memory that is extended using secondary storage, and then allowing CPU to access more memory space is already 2 marks. Data in use needs to be in main memory, so that data can be swapped. This one is 1 mark, and in temporarily created is another mark. So 4 marks in total. So better to write more if possible. And state one difference between paging and segmentation in the way memory is divided. Okay, so paging separates memory into fixed size blocks, whereas segmentation separates memory into a variable size blocks. Okay, then question number 9. Deep learning is used in artificial intelligence. Describe what is meant by deep learning. So deep learning is basically trying to mimic the human brain. It's actually learning that mimics the human brain. It uses artificial neural networks. So let's put uses artificial neural networks. That contain a lot of, or let's say an abundance, or let's put a lot of hidden layers modeled on the human brain. It uses many layers to progressively extract higher level features from the input. Okay, this will give you 4 marks. Artificial neural networks that contain a lot of hidden layers is really 2 marks. Model in human brain is another mark, and then many layers to extract higher level features from the input would be another mark, so total 4 marks. Outline the reasons for using deep learning. It basically it's used so that it can be used to identify hidden patterns. So here we can just say it makes good use of unstructured data. It enables machines to process data with a nonlinear approach and it is effective at identifying patterns. Alright, so makes good use of unstructured data is 1 mark, enables machine to process data with a nonlinear approach is another, effective at identifying patterns is also another 1. Right, so total 3 marks. Okay, then for question 10, we need to tick 1 box in each row to show if the statement applies to the reduced instruction set computer or the complex instruction set computer. Okay, the one that uses a smaller instruction set would be RSC. Okay, uses single cycle instruction, that one is also RSC. The one that uses fewer general purpose registers would be CISC. The one that uses hardwired and microcoder control unit would be CISC. Using a system where cache is split between data and instructions should be RSC. Okay, so this is the answer. And describe the process of pipelining during the fetch execute cycle in RSC processors. Instructions are then divided into 5 stages. If you can't remember the stages, is fine because there are other answers you can use. Each subtask, each stage is completed during 1 clock cycle. No 2 instruction can execute. Like for example, 1.2 and 2.1, they cannot be executed at the same stage. 1.2 and 2.2 can execute their same stage at the same clock cycle. Okay, that's 3 marks. And then the second instruction begins in the second clock cycle. While the first instruction has moved to its second stage. The third instruction begins in the third clock cycle. While the first and second instructions move on to the next stages. Move on to the next stage. This one gives you 4 marks, actually 5. Divided into 5 stages is 1 mark. Each stage completed during 1 clock cycle, another mark. No 2 instructions can be executed at the same time, 3rd mark. The second instruction begins in the second clock cycle, 4th. Third instruction begins the clock cycle, 5th. Alright. 11a define these object-oriented programming terms. So for instance, it's basically a specific object based on the class. Inheritance is the capability of defining a new class. Of objects from the parent class. And then polymorphism is basically when you allow the same method to take on different behaviors. Depending on which class. Is instantiated. Alright. So instance is when it's basically a specific object based on a class. Inheritance is basically the capability of defining a new class of objects from a parent class, but taking the new class of objects from the parent class. So like you have a parent class and then you have like the child class, something like that, then that's inheritance. And then polymorphism is allowing the same method to take on different behaviors depending on which class is instantiated. Basically just choosing the class and then it will then have different outcomes when you choose the different classes. Alright. So B, in OOP, a class contains attributes and methods. Complete the pseudocode for the class car to enable objects to be created. The class needs to include string attribute to store the make, model, body type, and field type, and integer attribute to store the number of cars that of the type built. Attributes must be only available through the methods of the class. Okay, so class here, put car, then private model. This is also string. Then private body type is also string. Then private field type, also string. Or if you don't want to put field, it's also okay. And then number of cars. This one is integer. Public procedure, new, car make string, car model, string, and then car field, car model, car make, and then car body type. It's also string. So your make would be from your car make, or the car brand basically, and then the car model goes into model. Okay, and then get field, get number built, and then get field, get number built, and then okay, and then you can just end the class. Alright, so that's the entire class for car. Alright, so you identify them, you then declare a private attribute of method, make, model, and body type and field type, these four. So everything is here. And then your integer attribute to store number of cars is here. Then you need to take the values from outside the class into the class itself by taking all these in. Then the procedure will then put everything into here, and then here are some of the functions, get field and get number built on the bottom of the outside the procedure basically, but still inside the class. Alright. In question 12a, the array named 0 to 99 is in alphabetical order. Complete this with code binary search algorithm. Okay. So lower 0, and then upper will be 99. Because this is the upper bound, as you can see, the lower bound is 0. Then we repeat. If upper is less than lower, then output target does not exist. If names mid is target, then lower is basically mid plus 1. And then if names mid is more than target, then then upper is mid minus 1. Because this one is a binary search algorithm, you're just basically making the search area smaller and smaller until you find the location. Basically until the point where names mid equals to target. Then that's how you shorten the boundary, basically. Like for example, in this case, right, we have a lower boundary and an upper boundary, assuming that we are talking about 0 until 5. This is your lower boundary, this is your upper boundary, and then this is your mid. Okay, so let's say if names mid or names tree is less than target, if your target is, let's say, 4 for example, sorry, if it's like 40 for example, but 40 is not in tree, then your lower will become mid plus 1. Mid plus 1 would be basically 3 plus 1 will get 4, so it will be between these two numbers, and then you'll be able to find out which is which basically. Alright. Then yeah. And then and afterwards you'll take mid, lower plus upper minus lower plus 1 divided by 2. Okay, then you get your middle number, and then you'll be able to find out whether or not it equals to the value in the array basically. Alright, and then here this one is end if, and then we just put repeat until. Then have to look at the boolean here. This one is exit equals to true. Okay, then B1, big O notation, is used to classify efficiency of algorithms. The big O notation for time complexity in the binary search is O log n, and state the big O notation for time complexity of a linear search. So linear search will be O bracket n. Describe the meaning of O log n as it applies to a binary search algorithm. It's basically time complexity that uses logarithmic time. Time goes up linearly. As the number of items rises exponentially. And then O log n is the worst case scenario. When comes to time complexity for binary search. Basically, this is because your time will go up linearly when your number of items rises exponentially. So you take even longer time to search for the particular data in your binary search algorithm. That's why it's the worst case scenario. It will take more time based on its formula. Alright. Okay, so this is the end of this paper. I hope you guys find this video helpful. Do share this video out to other people who may need help with computer science A2 level. As always, I hope to see you guys again in the next video. Till then, this is qiphyedu. Goodbye.